This is the last video for section 3.3. I'm on the last page of the handout. This is number 5 about the 2 trains. And of course I'm talking about distance again. So we're going to use rate times time equals distance, and I'm going to be making another chart. And like I said, if that's helpful to you, you can go ahead and do that. So I'm talking about, or in the problem, they're talking about 2 trains. Train 1 and train 2. And I'm just going to do rate, time, and distance. Okay. So let's fill in what we know. So a train leaves Orlando at 3 p.m. A second train, let's say that's train 2, leaves Orlando going in the same direction at 5 p.m. The second train travels 22 miles an hour faster than the first. Okay, that's talking about the rate. Second train travels. So we don't know how fast the first train is traveling, but we know the second train is traveling 22 miles per hour faster than the first. So I'm going to let x equal the speed of first train. Okay, bring that up a bit. And I know the second train travels 22 miles an hour faster than the first. How would I write that in math with the x and the 22? If it's 22 miles an hour more than, I could write x plus 22. Okay, so that's my rate column is filled in. What's going on with time? Okay, the first train leaves at 3 p.m. and overtakes the first train overtakes the second train at 9. So how many hours for train 1? He leaves at 3 and he gets there at 9, or overtakes at 9. So how many hours are passing by from 3 to 9? So that's 6 hours. So that's the time for train 1. And the second train leaves at 5 and meets up with the first train at 9. So how much time has gone by from 5 to 9? And that's 4 hours. So we want to find out what's the speed of the 2 trains. Whoops. Well, we've got that. We've got our variable in there, x, so that's good. Now we know rate times time equals distance, so we're just going to multiply across the columns. So x times 6 is just 6x, and then I'm going to multiply 4 times x plus 22. Okay, and they're meeting up. They left the station at the same place, and so they've gone the same amount of distance. So I'm going to set these 2 equal to each other. Okay, and I'm just going to do a regular solve. I'm going to do a distribute. I'm going to distribute this 4. So 4 times x is 4x, and 4 times 22 is 88. Okay, what's my next step? What do I need to do next? Well, I'm going to subtract 4x from both sides because I need my x's all on one side. So my 4x's are going to cancel out, and 6x minus 4x is 2x, so 2x equals 88, and I'm going to divide both sides by 2. The 2's are going to go. So x is the speed of the first train. So how fast is the first train going? 88 divided by 2 is 44. So this is the speed of the first train. And they want the speed of both trains. So this is the speed of the first train. What do I know about the second train? Well, we know it's going 22 miles per hour faster. So we just need to plug this 44 in for there, into that piece. So 44 plus 22 is how much? That's 66 miles per hour. And so that's the speed of the second train. So my answers are 44 miles an hour for the first train and 66 miles an hour for the second train. And again, if you need to pause and go back and re-look over the chart, how I worked out the problem, you can by all means do that, and also let me know if you have any questions in class or online. So I'm going to pause and let you try, bring this down, number 6. And if you want to make a table, you can. So if you're comfortable making the table, go ahead and do that. We're just going to do the same thing we did for number 5 and do rate times time equals distance. Make our 4 columns and fill them in and then work out the problem. So I'm going to come back in a couple of minutes. I'm going to pause and let you work on that and come back and you can get the answer. Okay, so welcome back. Here's my table for number 6. If you want to look at that and see what I wrote down for that, we're talking about driving to a football game and driving home or returning home from the football game. And as I read the problem, I know it took him 8 hours to drive to the football game. That's T is my time. And I know on the return drive, he only took 6 hours. So that's the time for the return. Now I want to find the speed for his return drive. Do I know how fast he's going when he's driving the 8 hours to the football game? I don't know his rate, so I'm letting x equal how fast he was going when he was driving to the football game. But I do know that he increased his speed by 17 miles per hour on the return trip. So I can say x plus 17 for the return. And then I just multiply across my columns and get the distance. This is 8 times x, which is 8x. And this is 6 times the quantity x plus 17. Make sure that's in parentheses. So I've got my 2 times, my rates, I don't know. I just know a little bit about the rate, the return rate going home. And then these are equal distances, so I'm going to set them equal to each other. And so that's what I did. I just set 8x equal to 6 times the quantity x plus 17. And I worked it out and I solved it. And I distributed this 6 out. And I got 6x plus 102. I subtracted 6x from both sides and got 2x equals 102 because my 6x's both canceled out. And then I divided both sides by 2, and 102 divided by 2 is 51. So I know that driving to the football game, he was driving at a rate of 51 miles per hour. But be careful, because they're not looking for that. They want his speed on the return drive. So if you put 51 miles per hour in the box in Hawks for the homework, it's going to count it wrong. So make sure you find out exactly what they are looking for. So they are looking for the average speed on Mike's return drive. So we know that he was going 17 miles an hour faster. So you just add the 51 and the 17 and you get the 68 miles per hour, and that's how fast he was going when he was returning home or on the return drive. So that's what you would fill in the box, the 68 miles per hour. So that's the end of the handout problems. Try the Hawks homework for 3.3 and let me know how it goes.